All right, guys, we're doing lesson 25, volume and surface area, and a lot of these are going to be real-world examples. We're going to start with this opening exercise, which says, what is the surface area and volume? So we're going to need to go back to both and have both of these things, surface area and volume, of the right rectangular prism. As we go through this, we remember that our volume is the area of the base times the height, and our surface area is just going to be the area of all of the sides added together. So let's start with volume. My base is 11 by 6.5, and that would be the base, so 11 times 6.5, and then I have to times that by the height, which is 10. So I would do 11 times 6.5 times 10, which is 715. And this would be inches cubed. So that's our volume. And then our surface area, SA, is going to be equal to the area of every face. And I know that this is a rectangular prism, so I have one on top, one on bottom, that's 2, front and back, that's 2 more, that's 4, and or left and right, and then front and back. So I know there's going to be 6 sides, and each pair is going to have, or there's going to be 2 that have the same area, right? So like this top and bottom are going to be the same area. So the top is 11 times the 6.5, and I can take that whole thing times 2 because there's 2 of those. This is maybe right, top and TB for top and bottom. Plus, I have to do these smaller squares left and right. So I'm going to take that times 2 because there's 2 of them. And they are 6.5 by 10. So 6.5 times 10 plus, and that is left and right. So that's 2 sides. So far that's 4 of my sides on this. And then I've done top and bottom, left and right. I need to do front and back. And there's 2 of those. And those are this side, which is 11 by 10. So they are 11 times 10. And then that's front and back. Whoops, that doesn't look like an F, but you get it. So then we can start doing our math. So we'll do 11 times 6.5 equals, and then I have to times that by 2, which is 143. And this would be inches squared because it's area. Then 6.5 times 10. When I times anything by 10, I'm basically just moving the decimal over. So this would be 65 times 2, which should be 130, but let's go ahead and check. 65 times, yep, 130. So this is going to be the left and right side added together is 130 plus 11 times 10, which is 110, because again, move the decimal over, just adds a 0, times 2, because this would be the front is 110 and the back is 110, so that's 220. And then, excuse me, I can add all these together. So 220, 130, and 143. Together would be 3. 2 and 3 is 5, plus 4 is 9, and 2, 1, 1 is 4. And this is surface area, so the surface area is equal to 493. Area is inches squared, not cubed. Okay. Example 1 says J has a small fish tank. It is the same shape and size as the rectangular prism shown in the opening exercise. A. The box it came in says that it is a 3-gallon tank. Is this claim true? Explain your reasoning. Recall that 1 gallon is 231 inches cubed. So if I want to know if it's a 3-gallon tank, how much water is fitting inside that tank, I'm not going to be concerned with the surface area. I'm not going to be concerned with the outside. I want to know the volume. And the volume was 715 inches cubic inches cubed. And it says 3-gallon tank. Well, we're in inches cubed, which is going to be, we're going to need to use this to convert to gallons. So if I know that 1 gallon is 231 inches cubed, I can take the volume that I know this fish tank is, which is 715 inches cubed, divided by what they tell me 1 gallon is in cubic inches, which is 231 cubic inches, and divide those two. Make 715 divided by 231, and that gives me 3.095. So 3.095 something inches, or gallons, sorry, because I'm converting to gallons. So is this claim true? It says it's a 3-gallon tank. Well, it's a little bit over 3 gallons, but if maybe they were rounding to the nearest whole number, which would be true. So yes, if rounding to nearest whole number. I'm going to use whole number. I'm going to use a pound sign for number. Okay, B says the pet store recommends filling the tank within 1.5 inches from the top. So they don't think that you should fill it all the way to the very top, that 10 inches. They just want you to fill it like, let me use blue, up to here, you know, the 1.5 from the top. So 1.5. So if it can go all the way to 10 inches minus that 1.5 from the top would be borrow all the way across. This is 0, 9, 10. So this would be 5.5, 8.5. So now the dimensions are not 11 by 6.5 by 10. They are 11 by 6.5 by 8.5, because they don't want you to fill it all the way. It will just overflow and make a mess. So how many gallons of water will the tank hold if it is filled to the recommended level? So first we need to figure out the new volume with it not being all the way up to the top. So let's multiply all these. 11 times 6.5 times 8.5, not 10, and that is 607.75. 607.75, and this is inches. Why do I keep doing it in inches cubed? And remember, if I'm trying to convert it to gallons, they gave me this in the last problem. 1 gallon is 231 inches cubed. So I can, again, divide by 231 inches cubed. So let's do our new volume divided by 231, which would be 2.63 we're rounding it off, gallons. So this would be our new capacity. C, Jay wants to cover the back, left, and right sides of the tank with a background picture. How many square inches will be covered by the picture? So, all right, so we have this same fish tank. Jay wants to cover the back and the left. So this is the left, this right side, and if I was to cut this off, the back, right? So only 3 of the sides. Now, I'm no longer in volume because I don't care about what's inside the fish tank. I'm just caring about putting a picture on the back, the left, and the right sides. So I need to figure out the area of the left side, area of the right side, which should be the same as the left, and the area of the back. And then add all of those together. So area of the left, I believe we were, what is it, 10 by, get these measurements in. This is, the height is 10. This is, 11. And this piece, or right here, is 6.5, I think. Let me double check. Yep, 6.5 by 10 by 11, which is back here. And this was, height was 10. Okay, so area of this left hand side would be a 10 by 6.5. So 10 times 6.5. The left hand side is also 6.5 by 10 times 6.5, and the back is an 11 long by 10 tall, so 11 times 10. And then we can add all of these together once we multiply. So 10 times 6.5 is 65. And again, 10 times 6.5 is 65. And 11 times 10 is 110. 5 and 5 makes 10. 6 and 6 is 12, 13, 14. And 1 and 1 is 2. So 240 inches, square inches of picture is what they're going to need to cover those sides in background. Do you water in the tank evaporates each day, causing the water level to drop? How many gallons of water have evaporated by the time the water in the tank is 4 inches deep? Assume the water tank is filled within 1.5 inches of the starting top. Okay, so a couple of things that we're going to need to know is, first of all, we didn't have the tank completely full. Remember, we had the tank when it was 1.5 inches from the top. So the volume for that we did up here, which 1.5 inches from the top was 607.75. Here is that 0.75. Let me see if I can get this to move. And this guy. So that was the volume when it was 1.5 inches from the top. Now I need to know the volume when the tank is 4 inches deep. So the tank is going to be still 11 long and 6.5 wide, but the height of it is only going to be not 10, but they said 4 inches. So if I did 11 times that's 6.5 wide times 4 inches deep is 286. Inches cubed, and this is inches cubed as well. It says how many gallons of water have evaporated by the time the water's in this tank is 4 inches deep. So I need to use the original volume of the tank depth with minus when it was 4 inches deep. So 607.75 minus 286.00. This is 5 and 7. 7 minus 6 is 1. 0, can't do that. Borrow, this makes that a 5. And this is a 10. So 2, 5 minus 3, 5 minus 2 is 3. So this is inches, cubic inches, and they want to know how many gallons. So remember, to convert it to gallons, we're going to do 321.75, which is the volume there, the difference in the volume, excuse me, divided by, if you remember back, 1 gallon is 231 cubic inches by 231. So we have 321.75 divided by our 231 is 1.39. We'll say approximately 1.39 gallons is how much has evaporated from the tank. All right, exercise 1, fish tank designs. Two fish tanks are shown below. One in the shape of a rectangular prism, that's tank R, and tank T is a trapezoidal prism, because we can see it has a trapezoid as the base, and this one has a rectangle as the base. That's where they get their names. A, which tank holds the most water? Let volume R represent the volume of the rectangular of tank R, and volume T represent the volume of this prism. Use your answer to fill in the blanks, meaning which one is less than the other, which one is greater than the other. So volume, we have to do area of the base times the height. And we want the volume because we want to know which one can hold the most water. So tank R, or T tank R, to find that we have to do 25 times, so that's our length, by 10, which is our width, by 15 times by 15 for the height. And tank T, let's go ahead and do this. 25 times 10 would be 250 times 15. So 3,750. This is inches cubed. Okay, so I know that tank T, again, we said has a trapezoid. So our formula for the area, because we have to do area of the base, which is the trapezoid shape, would be base 1, if you remember that area formula, or use your card, base 1 plus base 2 times the height divided by 2, or you can times by 1/2. Okay, so looking at our trapezoid, we know our base 1 is 25 plus our base 2 It doesn't give us a nice measurement for this, but up above here it does tell us this is 6, and I know then that this is also 6, and this piece is the same as this, so it's 25. So I've got 25 plus 6 plus 6, which is 12. So I'm going to do 25 over here plus 12, which 5 plus 2 is 7, so 37. I have to add those first. They're in parentheses times our height of this, of the trapezoid, not the height of the whole figure. So the height of the trapezoid is 8 divided by 2. So let's do this on our calculator. We've got 25 plus 37 equals times 8 divided by 2. I think I hit times 2. Let me try that again. 25 plus 37 equals times our height, which was 8, divided by 2. It's 248. So the area of the trapezoid of the base of B is, did I say 248? Yes. 248. Now I have to take the area of that trapezoid times the height of this 3D figure, which is 15. And that's going to equal 3,720. 3,720 cubic inches. Now I need to decide where to put these. This means less than. So blank is less than blank. And wants to write it in this vol. And which one of these is less than? Well, 3,750, 3,720. The volume of tank T is 20, or is 30 cubic inches less than the volume of tank R. B, which tank has the most surface area? Let SAR represent surface area of the right, and SAT be tank T. So surface area is just adding up the area of all the sides. I know that this shape has top, bottom, left, right, front, back, so 6 sides. And this one also has top, bottom, left, right, front, back, also 6 sides. So I have to find the area of all of those 6 sides here, add them together. Area of all the 6 sides on tank T, add them together and see which one has more. So doing our work here, this is tank R, is the rectangular one. I know that I have the front, this piece, the front, which is 25 by 15, and there's front and back are the same. So there's 2 of those, so I'm going to do 2 times, what did I say, 25 times 15. Plus, and then 2 times, okay, I did the front and the back. Now let's do the left and the right. The left, or the right side is 10 by 15, so the right will also be 10 by 15. Plus, and now we have to do the top and the bottom. There's 2 of those at the same size. And the top is going to be 10 by 25. So 10 times 25. Sorry, times 25. Okay, so that's the formula for all of those. Let's do 2 times that 15 times 25. 25 times 15 equals times 2, 750. So these are 7, this together is 750. Okay, 10 times 15 is 150 times 2. This would be 150 times 2 is 300. And this would be 10 times 25 is 250 times 2. 250 plus 250 is 500. So altogether, I'd have 750 plus 300 plus 500. 1550. So the area of R is 1550 inches squared, not cubed. Okay, let's go look at T. T, let's do left and right first. The left is 15 by 10. And there's 2 of those, left and right, so 15 times 10 plus, there's going to be 2 of the top and bottom. They're the same trapezoid shape. And what did we find for the area of that? We have to do area or base 1 plus base 2 times height divided by 2. And we figured that out to be base 1 was 25 plus 37 was base 2 times 8 divided by 2. Whoops. 25 plus 37 equals times 8 divided by 2, 248. And there's 2 of those. So I'm just going to write 248, and this is our trapezoid shape. Top and bottom, this is left and right, T and B, top and bottom, plus, and then we have to do our front and our back. Well, our front is going to be smaller than our back. Our front is 25 by 15. So 25 times 15 plus, and then our back was, if you remember this whole thing, which was 37, also by 15. So 37 times 15. Okay, so let's start working these out. We've got 15 times 10, 150, times 2 is 300, plus, this would be 248 times 2 is 496, plus 25 times 15, 375, and there's only one of those, so I don't have to times by 2, 375, correct? Yep. And then times 37 times 15. $555. Okay, and then I can add all those together. So 555. So let me move this up here. 555 plus 375 plus 496 plus 300. 1726. So T was 1726 inches squared. And so again, they're wanting to write it SAR and SAT, and which one is less than? Looks like SAR is going to be less than SAT. So surface area of R is less than the surface area of prism T. Water evaporates from each aquarium. After the water level has dropped 1/2 inch in each aquarium, how many cubic inches of of water are required to fill each aquarium? Show your work to support your answers. Okay, so we need to know what the original volume is minus the new volume on both of the shapes. So let's go through and look at this. The original volume on R, and the original volume on T. Let's go back and look at those. Original volume on R is 3750 and 3720 on T. So let's do 3750 and 3720. Those are going to be the original volumes, and I have to subtract that new volume where each of those is half an inch shorter. So instead of it being 15 tall, it's going to be half of that, which is, or half an inch shorter, which would be 14.5. So in order to find the volume, I do 25 length times width. That's going to give me the area of the base, and then times the height, which is 14.5. Oops. So I need to do 25, I think that's right. 25 times 10 times 14.5. So that would give me the area or the volume of the new, because it's not full, it's not to the 15 anymore. So 25 times 10 times 25 times 10 times 14.5. Whoa. $3,625. Okay, so it'd be the new volume, and then I'll eventually subtract and see what this would be. The original volume of tank T, the triangular or trapezoidal, is 3,720. Well, instead of doing times by 15 here, I would take the area of the base, which we already know is 248, times not 15, but a half inch shorter would be 14.5. So 248 was the area of the trapezoid times 14.5. $3,596. So I'm going to subtract that, 3,596. All right, and then I can subtract. Let's just start with the trapezoid tank, which is 3,000. The original was 3,720 minus the new filled, which is 3,596. That's 124. 124 cubic inches you would need to fill this aquarium to back to the very top. And then on the rectangular, be 3,750 minus the new volume, which is 3,625, be 125. So not too much difference. Oops, cubic. Don't forget cubic, I wrote squared. Inches cubed. So really, 1 cubic inch separates how much extra you would need to fill up the rectangular versus that trapezoidal shape. All right, so this exercise to design your own fish tank and the exit ticket we will work through tomorrow, as we do the lesson in class.